So these compound angle formulae, let's just have a look at them for a second. We're not going to worry about proving them, but let's look at them and see if they make sense. Just make sure we can use them, in other words. So let's look at this first one. What it's saying is, if I've got the sine of two angles, A and B, I can write that as the sine of one of the angles, A, multiplied by the cos of the other angle, plus the cos of the first angle times the sine of the second. I can split this angle, in other words, into two angles, and that comes in really handy when I'm looking at this. Because omega t, remember we talked about this, angular velocity times the time is one angle, and the phase angle, if there is one, is the other. So I can actually separate these two angles out using this identity. And so we can use that in AC theory, and actually also in any wave analysis. And if you carry on to look at the degree next year, then we'll be looking at Fourier transforms, and that involves exactly this sort of thing. So very useful again, but you're not going to come across them any other time other than if you move on with your studies, I guess. There's another one, sine A minus B, and if you look at it, it's almost the same as this one, only you subtract instead of add. And then we've got cos of A plus B, slightly different. Look, cos of A times cos of B minus sine of A times the sine of B. I remember it, I mean, if you do try and remember these things, plus becomes minus, and then minus becomes plus. It's the same. These two are the same, but different signs. So I can separate out sine and cosine functions that have two angles in them. And that can be useful. And they are the compound angle formulae. And we can use them to rewrite identities in different ways. What's another way I can write of sine A plus A? Using that compound angle, how can I rewrite sine of A plus A? Which one am I going to use? Top one. So that's going to be sine A cos A plus cos A sine A. For example, I can do that. But the sine of A plus A surely is the sine of 2A. A plus A is 2A. And if we look at these, sine A cos A and cos A sine A, they are exactly the same. So it's two lots of sine A cos A. And that's another identity. The sine of 2A equals 2 sine A cos A. And that actually is sometimes used in integration techniques in calculus. Another identity that we can come up with using these compound angle formulae. There's loads of these things, and we're not going to look at any more specifically now, but I've shown you a few examples of how we can come up with trigonometric identities, different statements to do with angles. Sines, cosines, tangents, cotangents, secants, and then we've got these identities that are combinations of them. Cos squared theta plus sine squared theta equals 1. Here's another one that we've just written down, and so on. Loads of these things. And if you were to use them a lot, you'd remember them. Okay, I'll stop that here.